Greetings to everyone. Today I am going to discuss the continuation of sigmatropic reactions, that is, its stereochemical discussion. Sigmatropic reactions are classified into two types. They are suprafacial sigmatropic shifts and antarafacial sigmatropic shifts. What are suprafacial and antarafacial sigmatropic shifts? Let us see with some generalized example. Suppose this is the molecule A single bond B, B double bond C, and here A is connected with the Z atom with a single bond. So this is the upper phase and this is the lower phase. If the migrating atom or groups, if it is retaining its position even after the migration, then we call that one as suprafacial. If it is changing its position or phase after migration, then we call them as antarafacial sigmatropic shifts. Let us see some examples to understand this in clear. So suprafacial sigmatropic shifts are those in which if migrating sigma bond with atom or group, if it retains orientation at the origin and terminate, those are called as suprafacial sigmatropic shifts. It implies it won't change or there is no opposition of phase by migrating atom or group. Then such sigmatropic shifts are called as suprafacial sigmatropic shifts. Here if you see in this molecule A, B, C, where A atom is connected with Z, this is a migrating sigma bond. If this sigma bond is migrating onto the C from upper phase to the upper phase, here in this case from A to C, it is in the N, in the product formation you can see the Z atom is at the upper phase only. So this is what we call suprafacial sigmatropic shifts. Now for example here in this case, in this alkene, the deuterium atom is migrated along with the sigma bond. Now this deuterium atom is from upper phase to, it is migrating onto the upper phase in this case also. So this is called as, this is 1,3 suprafacial deuterium shift. Now come to here in this case, here deuterium is in downside for example. Now if deuterium it is from downside to downside, if it is migrated, then we call this one as 1, 3 or 1,3 suprafacial deuterium shift. So in the orbital orientation, if you want to represent, okay, you can represent this molecule like this. Okay, this molecule, we have a double bond in between this one. So if deuterium it is migrating from this position to this position, from down phase to down phase, lower phase to lower phase, then we call this one as suprafacial sigmatropic shift. Here you can see in the product also, it is migrating from reactant, you can see it is the lower phase, and in the product also it is at the lower phase. This is called as suprafacial sigmatropic shifts. Now coming to the antarafacial sigmatropic shifts. In sigmatropic shifts where the migration of sigma bond with an atom or group is taking place with the opposition of its phase on pi skeleton. Now this Z atom or group, in this case, it is migrating from A to C. So here in this case, it is at upper phase, for example. Now in the product, if you see, the Z atom, it is now in the lower phase. So it is changing its phase, opposing its phase of migration. Then we call this one as antarafacial shift. So this is, as it is, the notation is same, 1 and it is 3. Okay, 1, 3 sigmatropic shift. Since the atom or group, it is changing its phase of orientation from origin to terminus, then we call them as antarafacial shift. So 1, 3 antarafacial Z shift, since Z atom is migrating in this case. It may be an atom or group. Now, let us take the previous examples only for explaining this antarafacial sigmatropic shift. So, in this skeleton, the deuterium atom is migrating with the sigma bond. So, if you see the product in this case, in the reactant, the deuterium atom is upper side, whereas in the product, the deuterium atom is at the lower side. So, if you want to represent the cyclic transition state, okay, this should not be there actually, sorry, and it should be like this. The transition state follows like this. Okay, this is the cyclic transition state. So somewhat longer transition state it is observed in this case. And here in this case, if you see in the next example, the deuterium is in the down phase, whereas in the product the deuterium is in the up phase, upper phase. So this is called as antarafacial sigmatropic shifts. So in an orbital orientation, if you want to represent this one, the deuterium which is connected with this orbital, Okay, the same molecule I am representing in the orbital picture. So the deuterium atom, it is migrating from this one, okay, the sigma bond which is there in between this p orbital and this s orbital. So this deuterium atom is migrating from lower phase to the upper phase. So in a cyclic transition state, it is proceeding and it is moving on to the upper phase. Here in this case, you can see in the product, it is at the upper phase. This is what we call antarafacial sigmatropic shifts. So if you want to clearly represent that one, okay. So this is the pi skeleton. If an atom or group, it is migrating from lower phase to lower phase. This is supraphase. Then, if you want to represent the low antarafacial, from lower phase it is moving on to the upper phase. This is antarafacial. Now, from upper phase, if it is moving on to the lower phase, this is also antarafacial. So this is a terminology stereochemical discussion in connection with the sigmatropic shifts. That is suprafacial sigmatropic shifts and antarafacial sigmatropic shifts. Thank you.